Okay, so now what we can do is take a look at an application, and for one of our applications it's finding the x-intercept. So recall what an x-intercept is. If I have a graph, right, we've graphed some lines before, right? So if my graph is a line, the x-intercept is a location where I'm crossing the x-axis. If my graph's a little more complicated, as a matter of fact, we're going to start graphing some parabolas here soon, but if I had a parabola, right, I notice that it's crossing the x-axis twice, right? And then sometimes we have a cubic graph, something to the third power, and cubic graphs look like this, and we notice they're actually crossing the x-axis 3 times. So x-intercepts are points, right, or locations where we are crossing the x-axis. And algebraically what happens, right, the way that we find them is we let y equal to 0, right? Because this number right here would be some number, but we know for a fact that 0 would be the y coordinate. For these two guys, right, either one, there's some number for the x-axis, and then 0 is definitely the y coordinate. And then same thing for here, right? We have 3 different x values, so whatever that number is, but at each location we know y is equal to 0. So algebraically, that's the way we find them. So visually, they're locations where we cross the x-axis. Algebraically, what happens is y is equal to 0. And so check out what happens. So if I'm going to find the x-intercepts for y equals x squared minus 25, right, we begin this journey by letting y equal to 0, because I know that's what has to happen. So if I let y equal to 0 here, lo and behold, what I end up with, I know it's on the reverse side, but I have a polynomial equal to 0. And so that's basically the lesson. So how do we solve this? We factor this. This is a difference of squares pattern, so x plus 5 times x minus 5. And I now have a product equal to 0. So the 0 factor property again is in play. So we now know that x plus 5 is 0, or x minus 5 is 0. And so subtracting 5, we end up with that as an answer. Adding 5, we end up with that as an answer. Okay? But what's different is we are looking for a point, right, that's on the x-axis. So my answers in this case aren't just x equals negative 5 and x equals 5. It's the point negative 5, 0, and it's the point 5, 0. And so later on in chapter 11 in this course, we are actually going to graph this. And whatever the graph looks like, we know that it's crossing the x-axis at negative 5, 0 and at 5, 0. For those who are in the know, it's a parabola. And so that's basically visually what we found. We've located the 2 locations where this graph crosses the x-axis. More on this graph later, right? But right now we're at least able to identify where it's crossing the x-axis using what we're learning, factoring in the 0 factor property. So the next one, making this a little harder. Again, we're trying to find the x-intercepts for this equation, y equals x squared plus 2x minus 8. Well, again, we start that journey like we start all x-intercept journeys by letting y equal to 0. And when I set y equal to 0, again, it's kind of in reverse, but I have a polynomial equal to 0. So we're back to let's factor and use the ZFP. Again, I'm going to use the guessing and checking routine, right? So first times first, well, x times x. And then to get a negative 8, I believe plus 4 and minus 2 will be the right combination, right? First times first is first. Last times last is last. Outer and the inner give me a positive 2x. So we're factored. So the 0 factor property says maybe the x plus 4 is 0, or maybe the x minus 2 is 0. Subtract 4 from both sides, and we get negative 4. Add 2 to both sides, and we get x equals 2. And then again, in the past videos, we stopped, but we now, right, are finding locations, we're finding points on a graph that cross the x-axis. So my x-intercepts, right, the correct value, or the correct answer would be negative 4, 0, and 2, 0. And again, just snap ahead. This graph, again, is going to be another parabola. One of its x-axes, one of its x-intercepts is at negative 4, 0, and the other is a 2, 0. And we'll figure out how to do the rest later, but I know at least that's where it's crossing the x-axis. That'll come later. Last one, right? So we have y equals 3x squared plus 4x minus 4. Again, how do I find the x-intercepts? Everything starts by letting y be to 0, right? That's the constant fact about an x-intercept. So set it equal to 0, and now I have a polynomial equal to 0. So we factor to set up the zero factor property. First times first, I believe that's the only way to get that done, right? And then, oops, got 3x, x right there. All right, so we got that. And then how about, I think if we do 2 and 2, make that a positive, make that a negative. So first times first is 3x squared. Last times last is a negative 4. And then when I do my inner, I get a negative 2x. When I do my outer, I get a positive 6x, giving us that positive 4x. So there's our factorization. And so the zero factor property now says that maybe the 3x minus 2 is 0, or maybe the x plus 2 is 0. So we just solve what's left. Okay, and again we're finding points. So the correct answer would be 2/3, 0, and negative 2, 0. So again, we have another parabola, and that parabola, the sketch would be, right, crossing the x-axis at that data point and at that data point. All right, so there's an application. So many more, all right, but we're going to move on and learn those in many more chapters and a lot of other situations. So that should truly wrap up Chapter 5. Again, if you guys have questions, if you're misunderstanding some things, you have lots of options to get help. Post your question on Canvas, send me an email with your questions, request a Google Meet time, right, where you and I can talk one-on-one and go over your questions. Lots of help available, including all the help features in the My Math Lab as you do your homework. So make sure you're using everything you need. Talk to you guys later.